Well, I'm awfully glad to be here. I'm actually a local, so I didn't have to get on an airplane to do this talk, which was pretty exciting. That was a terrific setup from Dr. Al Mohler. I was kind of wondering exactly how I'd introduce this talk, and he made it so easy. I'm wondering if this session was intelligently designed. He asked this question: what is why is there something rather than nothing? And the author James Meyer, who's written a number of great books about worldview, calls that question the prime reality question. And I like to reframe that question just slightly and put it this way: what is the thing or the entity or the process from which everything else comes? And in our elite culture, our elite knowledge culture, as Dr. Mohler referred to it, the answer to that question has been given over the last 150 years or so in strictly materialistic terms. The thing or the entity from which everything else comes is matter and energy, and purely materialistic processes such as natural selection acting on random genetic mutations. And so there has been not only the idea of materialism, but the idea that science, properly understood, supports this materialistic worldview. In particular, the science of Darwinian evolution, because Darwinian evolution gives an account of the most difficult thing to explain the origin of. And the most difficult thing to explain is the origin of life. Life is the most complex and exquisitely beautiful thing on Earth, and Darwinian evolution has provided an answer, or alleges to provide an answer, for the origin of the very first, of every new form of life from simpler pre-existing forms of life. And there's an auxiliary theory that complements it called chemical evolution that attempts to explain the origin of the first life from simpler pre-existing chemicals. So the evolutionary theory has provided an indispensable plank in support of this materialistic worldview about which Dr. Mohler was speaking. Now, I'm going to talk today about whether or not the evidence supports this materialistic worldview, and I'm going to do that by way of examining the evidence for this proposition of Darwinian evolution. Now, my book begins with a story, and the story is the story of Darwin's own doubt about his theory. I begin the book with a line: when Darwin finished his great masterpiece, The Origin of Species, he thought he had explained every clue but one. And the clue that he knew he hadn't explained was an event in the history of life known as the Cambrian explosion. Now, the Cambrian explosion is the geologically sudden appearance of most of the major groups of animals that have ever existed on Earth, at least at a certain level of biological classification known as the phyla. The phyla represent the largest divisions of animals in the animal kingdom, and each phylum represents a unique body plan. And the mysterious thing about the Cambrian explosion from a Darwinian point of view is precisely that these forms of life emerge so suddenly, geologically speaking. When they come into the fossil record, they do so without any apparent connection to any discernible ancestral forms in the lower Precambrian strata. If you remember your basic geology, the oldest stuff is on the bottom, all other things being equal, and the newer things are on the top. Things pile up over time, so the older things are on the bottom. As you look at the sedimentary record, you see all these different forms of life emerging very suddenly or abruptly. I have on the slide behind me a nice graphic that one of our graphic artists helped us produce. You see the sedimentary column on the right, your right. You see some of the representatives of the new animal forms that come into the fossil record, and you see the geological time scale rendered in millions of years, as geologists do, on the other column. And you see that there's a very discrete pulse of what's called morphological innovation in biological form, new forms of life, and you see beneath that the absence of the ancestral forms that would be expected based on Darwinian's theory. In the standard geological way of dating, the Cambrian period is the first period of the Paleozoic era, and it started about 543 million years ago, and the explosion occurs about 530 million years, and the most explosive pulse of that explosion occurs within about a 5 million year window, or 1/10 of 1% of the Earth's history, which geologically speaking is a blink of the eye. Now, I know there are many different views, even within the Christian world, about the age of the Earth. And I want to ask you, whatever your view is on that, to set that aside, because it really doesn't matter what your view is on that. Notice the pattern here. The pattern is what's important. You have a very discrete pulse of innovation, very sudden, geologically speaking. And from a biological point of view as well, even 5 million or 10 million years, as the explosion is often dated, is not only a geological blink of the eye, it's a biological blink of the eye. Because biologists have in fact, evolutionary biologists have a subdiscipline of their field called population genetics that allows evolutionary theorists to calculate how much evolutionary time or how much evolutionary change could take place in a given period of time if they know certain factors: the mutation rate, the time from one generation to the next, the size of a population, and so forth. And as scientists have begun to calculate how much change could take place in a given period of time, when they need, for example, even just 2 or more coordinated genetic mutations, what are called waiting times go right out the roof. They rise exponentially, and once you get beyond 2 coordinated mutations, the expected waiting time, based on these equations of population genetics, the mathematical expression of modern Darwinian theory, suggests that we would have to wait much longer than the age or the period of time that life has been on Earth, beyond several hundred millions of years. So a 5 to 10 million year window in Darwinian time is a blink of the eye. It's not nearly enough time for the mutation natural selection mechanism to get the job done. So whatever your view of the age of the Earth is, you have to realize that from a Darwinian point of view, this sudden appearance of all this new form and structure is very unexpected. It defies the explanatory power of the Darwinian mechanism. It defies the creative power of that mechanism. And so you have kind of a puzzle, and Darwin was aware of it in an incipient form in the 19th century. Here's what he would expect to see in the fossil record based on his theory. You'll remember he depicted the history of life as a great branching tree, where the branches at the top of the tree represent all the forms of life that exist today, and the trunk or the root of the tree represents that first primordial form of life, probably a simple one-celled organism. And all the connecting branches represent those forms of life that have gradually evolved and changed and morphed from that simple one-celled organism to produce all the forms of life we see today. But instead of seeing in the fossil record a picture of gradual and continuous change, the great tree of life, instead what we see in the history of animal life is something like this, something more like a lawn instead of a tree. So there's this tension between the theory on the one hand and what the fossil evidence actually shows on the other. Now, Darwin didn't doubt that his theory was true. He was convinced, he had advocated for it very forcefully in The Origin of Species, but he did doubt that his theory was able to explain all the relevant evidence. And the fossil evidence in particular tripped him up. He was concerned about it. And this is what he said right in The Origin of Species itself. He says, to the question as to why we do not find rich fossiliferous deposits belonging to these assumed earliest periods prior to the Cambrian system, I can give no satisfactory answer. And this I call Darwin's doubt. Now, I like to contrast Darwin's rhetorical modesty, his willingness to acknowledge problems with his theory or weaknesses in his argument, with the tendency of modern defenders of Darwinian theory, what's called modern neo-Darwinism. I had the opportunity a couple years ago to testify before the Texas State Board of Education. At the time, the board was considering a rather innocuous-seeming state science standard that was to encourage teachers to present to students the strengths and weaknesses of competing scientific ideas and theories. The Darwin-only science lobby turned out in force, and they were opposing this idea because, in the words of Eugenie Scott, the president of the National Center for Science Education, there are no weaknesses in the theory of evolution. Now, I found this to be rather actually shocking statement, because I was there at this hearing to present into evidence 100 peer-reviewed scientific articles that were raising problems with contemporary Darwinian theory. These were articles from mainstream biology journals, many even written by evolutionary biologists and evolutionary theorists. So I knew full well there were plenty of weaknesses with contemporary evolutionary theory. But one of the themes of my book, the new book, Darwin's Doubt, is that there is a huge disparity between the public presentation of the status of Darwinian theory in textbooks, by public spokesmen for Darwinian theory, such as Eugenie Scott and Richard Dawkins and others, on the one hand, and the actual status of the theory as you find it in the peer-reviewed scientific literature in biology and even in evolutionary biology and evolutionary theory. The public hasn't gotten the word yet, but even many leading evolutionary biologists now are calling for a new theory of evolution precisely because they recognize that the central mechanism of modern Darwinian theory, the mechanism of natural selection acting on random genetic variations, lacks the creative power required to explain events like the Cambrian explosion. It does a great job of explaining minor variations. Galapagos finches and their beaks getting a little longer or a little shorter in response to varying weather patterns. Or the famed peppered moths in England that got darker and lighter and darker again in the population in response to the varying levels of pollution. But these are cyclical variations within an established limit. They do not explain where we get moths or birds or indeed animals in the first place. And many leading evolutionary biologists today are saying things like neo-Darwinism explains the survival but not the arrival of the fittest. It explains small-scale variation, but it does not explain what is called morphological innovation, innovation in form and structure. And so, despite these kinds of very candid admissions about the limitations and weaknesses in the contemporary version of Darwin's theory, we still have people like Eugenie Scott and Richard Dawkins saying things like, as Dawkins said in this in an interview with the New York Times, it's absolutely safe to say that if you meet somebody who claims not to believe in evolution, that person is either ignorant, stupid, or insane. And then he said, by way of concession, or wicked, but I'd prefer not to consider that. That was sporting of him, I thought. By contrast, Darwin was very candid. And in his great work, The Origin of Species, he said, the case, referring to the Cambrian explosion, at present must remain inexplicable and may be truly urged as a valid argument against the view here entertained. Now, I called, in writing about the Cambrian explosion, I have focused on two separate but related mysteries. And the first mystery I call the mystery of the missing fossils. And what I do in the book is I tell the story of Darwin's doubt, his doubt about the ability of his theory to explain the Cambrian explosion, and I trace what has become of that doubt. I tell the story of what's become of that doubt, because I contend that that doubt has grown up to become a major problem, illustrative. It has become illustrative of a major problem in all of evolutionary theory. For Darwin, it was that one troubling anomaly, that one small thing that he thought his theory couldn't explain. But that small thing has grown up to become a much bigger and more fundamental problem, and I'd like to explain that in a little more detail. As I said, there were two aspects to the mystery of the Cambrian explosion. And the first is what I call the mystery of the missing fossils, those missing ancestral fossils in the lower Precambrian strata. Now, Darwin was a great scientist, so though he acknowledged the problem, he was already thinking about how he might, or how someone might be able to eventually explain it. And he had a charming metaphor which he used to get across his idea about what might eventually resolve the mystery. He said, "I look at the natural geological record as the history of the world imperfectly kept. And on this view, the difficulties above discussed are greatly diminished." His idea was that the fossil record was incomplete. And if we looked a whole lot more and a whole lot harder and concertedly over a number of decades, we would surely find those missing ancestral fossils. In Darwin's time, he knew about the Cambrian event primarily because of a few basic forms of animal life that had been well preserved and, and extensively documented in the 19th century. One of those forms of life is the iconic trilobite. You've probably seen them. As a little kid, I was fascinated with not only dinosaurs, but also trilobites. And trilobites have three distinctive lobes. They have compound eyes that can actually be, the cone-like structure of the compound eye is actually visible in many trilobite fossils. So you have this extraordinary complexity and a sophisticated visual organ present in animal form from the very dawn of animal life. It's very extraordinary. And Darwin was aware of trilobites. He also knew about another form of life, common animal form called a brachiopod. It had a shell of two unequal parts in a feeding organ called a lophophore. Now, Darwin hoped that subsequent fossil finds would fill in the gaps, would establish that there had been a gradual transformation from simple to complex in the lower Precambrian strata. Unfortunately, for proponents of Darwinian theory, that's not what the great fossil finds of the 20th century have documented. Instead, they've actually made the Cambrian explosion they've made the mystery of the Cambrian explosion more acute. The first great fossil find of Cambrian-era fossils occurred in Canada in 1909, at a place in Canada just across the border from Alberta in British Columbia. This is the famed Burgess Shale find near Field, British Columbia. These fossils were discovered in 1909 by the Smithsonian scientist Charles Walcott. He was prospecting in the high Canadian Rockies, and as the story goes, his mule slipped into a talus slope of loose pieces of shale right near the end of the prospecting season. And he turned over some of the pieces of rock to get his horse out, or his mule out, and he discovered exquisite forms of marine life preserved high in the Canadian Rockies. This is a picture of one of the fossils that he found. It is a delicate lace crab, unknown in our time, extinct today, but an extraordinary creature. And you can see how beautifully resolved, how beautifully preserved this creature is in this dark shale rock. And there were many such exquisite creatures found, of which scientists had previously no knowledge. And so rather than a few basic forms of life missing ancestral forms, now as a result of the Burgess find, there were many forms, exotic forms of animal life that had been unknown before, each of which was also missing ancestral forms. So the explosion became, from our point of view, more explosive, or we learned that it had been more explosive. More forms of life and even more gaps to be filled in. Here's another iconic form from the Canadian Rockies. This is a creature called a waptia. It's a crustacean, and you can see the segmentation in the tail beautifully preserved here. It looks a little like a shrimp. And so the Burgess documented that the explosion had been much more explosive than had been previously known. Then in 1984, there was another just absolutely extraordinary fossil find. This in southern China, near the town of Changjiang in the great country of China. And here, again, the fossil finds accentuated the problem of the Cambrian explosion, in part because the scientists were able to pin down the dating of this with the radiometric methods, and they found that the period of time of the explosion had been even much shorter than had been previously believed. It was cut in half by about, it was about 25% of the time that had previously thought. And again, the explosion documented many new forms of life that had been previously unknown, and they were beautifully preserved. In fact, there was a Time magazine cover story about this find in 1995, and the period of time of the Cambrian had shrunk so much that one paleontologist said, "What I like to ask my evolutionary biology colleagues is this: how much faster does this have to happen before we stop calling it evolution?" Now, in the year 2000, we at Discovery Institute had, and we're right here locally in Seattle, we had the chance to sponsor a lecture at the University of Washington from one of the leading Chinese paleontologists, one of the paleontologists who'd been right at the forefront of making these extraordinary discoveries in southern China. And his name is J.Y. Chen. And Chen came to the University of Washington bearing gifts. He had fossil samples galore. And as a result of that, many of the professors from the University of Washington in the geology department, the paleontologists, and the evolutionary biologists in particular turned out in force. And Chen gave just an absolutely spellbinding lecture on the many different forms that had been established, forms of animal life that had been established in this Chinese Cambrian layer. One of which was a creature called an anomalocarid, which was the predator of the Cambrian seas, the top of the food chain, about 1 meter long, with these giant appendages and a round mouth, and all these different, very exquisite anatomical features preserved brilliantly in this honey-colored shale in southern China. There were hyoliths, conical-shaped animals that lived in a shell with an attached lid. There were phoronitids, a filter-feeding organism with basically a worm in a tube. There were other forms of worms with little segmented bristles, lateral bristles for locomotion, and on it went. There was even an animal form that looked like a plant called a dynamiscus. This was so unusual in its structure that the paleontologists didn't know quite how to classify it, so they just called it a problematica. You're starting to see how scientific terminology works. Yeah. And one of my favorites was a beautifully preserved comb jelly. Now, this is 530 million years ago, and I have on the screen a picture of a modern comb jelly as we might find one out in Puget Sound, and you can see that the structure of these two organisms is almost identical. In paleontology, they call this stasis, lack of directional morphological change. In other words, no evolutionary change in over 500 million years. Absolutely extraordinary. And on Professor Chen went. Near the end of his lecture, he held up his hand and used it as a visual aid to make a very compelling point. He said, these new animal finds in the Maoshishan Shale in southern China have turned Darwin's tree of life upside down. In the Darwinian metaphor of the tree implies that the change moves gradually from simple to complex. But instead, what the fossil record shows is the very first forms of animal life come into the fossil record fully formed with an extraordinary integrated complexity, in each case exemplifying a unique body plan. So there's no gradually changing things connecting the different forms of life. They simply appear fully formed. Now, this is really puzzling from a Darwinian point of view, and Chen's lecture expressed some considerable skepticism about the adequacy of Darwinian theory. At the end of the lecture, there was time for Q&A. And one of the professors from the University of Washington, our great local research university, by the way, is one of the leading research universities in the world. One of our professors raised his hand and said, "Professor Chen, it was a fascinating lecture, But aren't you a little nervous about expressing skepticism about Darwinian evolution coming as you do from a communist country? Suddenly there was a kind of awkward silence in the room. But Professor Chen, nobody's fool, got a wry little smile on his face. And he said, well, in our country, we can question Darwin, just not the government. In America, you can question the government, but you can't question Darwinism. It was his way of saying, whose country is more free, really? He'd heard about political correctness in the American universities. In any case, he made a fascinating presentation of just how explosive we now know the Cambrian explosion to have been. In 2009, there was an even additional piece of evidence added to that, as scientists discovered that in the Cambrian layer, there were even fish fossils were now known, that fishes which were previously known to have arisen much later were first also present in the Cambrian. So this is an extraordinarily explosive event from a geological point of view. It's typically dated using the radiometric methods at about 10 million years. The most explosive pulse of that morphological innovation has been dated to be about 5 to 6 million years, in which time between 13 and 16 distinct animal body plans first arise in the Cambrian period. Even Richard Dawkins has acknowledged it's as though they, the animal phyla, were just planted there without any evolutionary history. Everything with Dawkins is as if, okay? Life looks as if, his first line of The Blind Watchmaker, biology is the study of complicated things that give the appearance of having been designed for a purpose. The appearance, but not the reality, of course. Now that's the first mystery. And in the book, Darwin's Doubt, I not only explain how the mystery has been made more acute, but I also look at the various progressive attempts that have been made to solve the mystery of the missing fossils and show why, one by one, they have failed. But I want to get on today to the more fundamental mystery. And this gets to some of the points that Dr. Moeller raised. And this is, in a sense, a much deeper question than just gaps in the fossil record. This is the question of causation. What caused those animals to arise? Or we could think of this as an engineering problem. How do you build an animal? How would the evolutionary process have produced these complex forms of life, given that it requires a great deal of time to work, and given that it relies, we now know, on unguided, undirected copying errors in genetic information? That's the idea of mutation. The modern mechanism of evolution is said to be natural selection acting on random genetic mutations. And mutations are essentially copying errors in genetic material, in genes. Now, this mystery has presented itself to us with particular difficulty because of the discoveries of the second half of the 20th century in the field of modern molecular biology. It started in the 1950s with the famed duo Francis Crick and James Watson. In 1953, they elucidated the structure of the DNA molecule, a molecule that had been, over the last decade, increasingly suspected to be the source of hereditary information. In 1957, Francis Crick went further. Crick did not, at the time of his discovery with Watson, even have a PhD. He wasn't a biologist. He was working on a PhD in physics. He had, however, fittingly been a cryptographer in World War II, a code breaker. And fittingly, he ended up helping to break the ultimate code, the code of life. In 1957, he put forward a famed hypothesis known as the sequence hypothesis, in which he proposed that the four chemicals that you see running along the interior of the DNA molecule, and I have the image of the DNA molecule on the screen behind me. You recognize its familiar helical shape with the four chemicals on the inside, which are called nucleotide bases. Crick proposed that these bases are functioning in DNA like alphabetic characters in a written language or digital characters, the zeros and ones in a section of software. That is to say, it's not the shape of these molecules that matters or their chemical properties. What matters to their function is the arrangement of these characters in accord with a symbol convention. That is to say that they are literally carrying instructions for building the proteins and protein machines that cells need to stay alive. An absolutely extraordinary hypothesis. It took about 6 years for this hypothesis to be confirmed by a whole series of experiments that were being performed on both sides of the Atlantic Ocean. But confirmed it was, and our current understanding of life is very much dependent on what Crick realized. That inside the DNA molecule, we literally have information, and information of a kind which is familiar to us in two respects. The information in DNA is highly complex. That means it's not just a repetitive pattern. It's not a mantra. It's not it's not the same letters repeating over and over. A-T, 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 A-T. Instead, it's complex and unpredictable and aperiodic. But it's also specified. That is, the arrangements of the characters in the DNA molecule are specific in order to perform a communication function. In particular, the function of conveying information to the cell's manufacturing system about how to build the proteins that the cell needs to stay alive. So if we think of two different kinds of information which is complex but not specified, which has no meaning, and engineers actually have a theory for describing this type of information and measuring it, that's not what we're talking about in biology. It's not a string of characters like the one on the top of my slide behind me. It's a string of characters much more like the one on the bottom, which are complex, meaning they're not repeating over and over again, but they are specifically arranged to perform a function. That's what we have in DNA. We have information that is functional. Now, what's this got to do with the Cambrian mystery and the Cambrian explosion? Well, quite simply this. If you want to build an animal, you need a lot of new information. In fact, I used to ask my students a question to get this idea across. If you want to give your computer a new function, what do you have to give it, I would say. Since you're not students, I will leave that rhetorical question hanging. But you can imagine the answers. Code, information, software, instructions, all of those are correct answers. And it turns out the same thing is true in life. If you want to build a new Cambrian animal, we now know that you need a whole bunch of new types of cells. Not just new cells, but different types of cells. In the Precambrian, there were simple creatures called sponges. But these Cambrian fishes I showed you a minute ago required 60 or more cell types, whereas the sponges 6 to 10. So there's a big jump in complexity as measured by the types of cells required. But for each new type of cell, you need new proteins, new dedicated proteins. Worms, which arose in the Cambrian, have a gut. Guts require digestive enzymes. Enzymes are types of proteins requiring code to build them, genetic information stored in DNA. So to build each new form of animal life with all these new cell types, you need all kinds of new proteins. And each new kind of protein requires more genetic information. Now that's where things start to get sticky from a modern or neo-Darwinian point of view. Because we know something about systems of code or informational text. If the systems are functional, random changes are not friendly to maintaining function. Random changes tend to degrade function rather than to enhance function. I was standing on the soccer sideline one day with my daughter when she was watching my daughter play when she was 12 years old. Her soccer coach, who is a software engineer from Microsoft, one of their elite architect level programmers, walked over to me. I didn't know he had any idea what I did for a living. And he leaned over like this and he said, "So what do these Darwinists think? The code just wrote itself?" And then he said, "Not at Microsoft. It doesn't work that way." Now, this is a big problem And intuitively, there's a reason that random changes tend to degrade information before you ever get to any new operating system or program in software, or any new sentence or instruction manual in English. And that is, there are many more ways of arranging characters in all linguistic systems that are going to go wrong than there are ways of arranging things that will go right. Okay? So you could think of this as like a big number of possible ways of arranging English letters or zeros and ones in software. That's represented by the big circle. And the ones that are functional is represented by the little dot, a tiny needle in a big haystack. Now, in 1967, there was a group of MIT scientists who were having a picnic. And it included some of the distinguished professors of physics and engineering and computer science at MIT who were having conversations with their biology colleagues. And they said, look, if you guys are right that DNA is functioning like a code, if it's a typographic system in which there are characters that are conveying information, then we don't get how random mutations are ever going to generate the new information you would need to build any new proteins, let alone whole forms of life. That seems to us to be incredibly, overwhelmingly improbable that would ever occur, precisely because there's so many more ways to go wrong than there are ways to go right. Now, I've got a way of illustrating this that gets at what was bothering these MIT math guys. And it's a bike clock. And we're all familiar with bike clocks. 4 digits, 10 dials on each. That means there's 10 times 10 times 10, or 10,000 different ways of arranging the digits on the bike clock. But only one will open the bike clock, right? Now, you can't imagine situations in which you could open the bike clock by chance, but that would require a lot of time. And so there's a kind of calculus you have to go through to decide whether a random search for a functional sequence of text or any functional information is likely to be is going to be plausible, whether it will likely to succeed or not. You need to know how much time you have in relation to the number of things that have to be searched. If the number of things that if the thing you're looking for is extremely rare and you have only limited time to look, it's going to be much more likely that you'll fail than it is that you'll succeed. So if we got a guy out here wanting to steal a bike and he encounters this 10-dial lock, I've made a little calculation. If he can do one thing per 2 seconds, one new combination per 2 seconds, and he's really persistent, in just about 3 hours, he could get through half the combinations, in which case it would be more likely than not that he could open the lock by chance. But what if he encountered a lock like this? In this case, he's got to be really persistent. In fact, his lifespan is not going to be sufficient to sample more than half of the lock. So the big question is, when we're looking at coming up with a new gene, which is a big section of information in DNA, enough to build a protein, is it more like the first situation where there might be enough time for a random search to succeed, or is it more like the second situation in which there's not nearly enough time? Well, I go into all the details of this in the book, but there's a scientist who's investigated this very carefully. His name is Doug Axe. He worked on some experiments to settle this question at the University of Cambridge. He was at it for 14 years. And he determined that the bike lock in question is not one with 10 dials, it's one with 77 dials. That's how hard it is. That's how much gibberish there is. There's 10 to the 77 possible ways of arranging all the characters in the genetic code, a section of genetic text for every functional protein the text codes for. In which case, even 10 to the 40th organisms, which is the number we've had in the history of life on Earth, is not enough to search that space and give you any reasonable probability of generating even one new gene or protein in the known history of life on Earth. So we're much more in the 10-dial lock situation, is the bottom line. And the real bottom line is that the mutation selection mechanism is not a sufficient means for generating new genetic information. It's much more likely to fail than to succeed, even on the scale of the whole history of life on Earth, which means the hypothesis that it did succeed is much more likely to be false than true. And that's a problem for the neo-Darwinian mechanism. Now, there are some other difficulties, and I go into them in the book. This is just one of 5 key problems with the neo-Darwinian mechanism. It can't generate the new genetic information that's necessary, but there are other complementary and even deeper problems. I'm going to skip over those in the interest of time and explain why, on the other hand, I think there is positive evidence for intelligent design. I was first introduced to the idea of intelligent design in the mid-1980s. I was a young scientist working as a geophysicist for an oil company. A conference came to our city at the time in which I first encountered an author named Charles Thaxton, who had written a book about the origin of the very first life. And he at the time suggested that the information-bearing properties of DNA intuitively suggested the activity of what he called an intelligent cause. He said that intuitively, information is a kind of mind product. It's something that comes out of minds, not material processes. And I began to wonder, after I got to know Dr. Thaxton, he was something of a mentor to me in the year before I went to do my graduate work. And as I set off to Cambridge in 1986, I began to wonder if it was possible to formulate this intuition that information points to intelligence as a rigorous scientific argument. Could the design hypothesis, as it was known historically, be reformulated as a rigorous scientific argument? Ironically, in order to investigate this question, I became very interested in Darwin's method of scientific reasoning, because Darwin knew that that to investigate events in the remote past required a different kind of scientific reasoning. He couldn't repeat the origin of trilobites under controlled laboratory conditions. That wasn't going to happen. So he had to use a method of scientific reasoning that was much more like forensic science, where you infer the cause of events in the remote past from the clues that are left behind. And this method is called the method of multiple competing hypotheses, or the method of inference to the best explanation. But that raised a really crucial question. What does it mean in an historical or forensic science to be the best explanation? And the scientists of the 19th century worked this out in very practical terms. One of Darwin's mentors, in fact, the famed geologist Charles Lyell, laid out a very clear and common sense criterion to decide what made an explanation for any given event in the past best. And one day I was reading the front piece, the title page of his book on geology, and had a long Victorian subtitle. And just at that moment, before I was to fall asleep in boredom, this phrase hit me: being an attempt to explain the former changes of the Earth's surface by reference to causes now in operation. The best explanation, said Lyell, is a cause now in operation, a cause known from our present experience to have the power or capacity to produce the effect in question. Illustration: if you go to Eastern Washington today, where I used to teach, out in the Palouse country, you will still find little patches of white volcanic ash. White ash. If you're a historical scientist and you did not get to see what happened on May 18th, 1980, you would have to use Darwin's historical scientific method. You'd have to infer the cause from the effect left behind. But which cause? Well, then you'd have to propose different hypotheses. Maybe it was a flood. Maybe it was an earthquake. Maybe it was a volcanic eruption. According to Lyell's criterion, which one is best? Obviously, anyone? The volcano. Why? Because it's a cause now in operation. It's a cause which is known from our present experience to have the power to produce the effect in question. What's this got to do with the Cambrian explosion? The origin of the information necessary to produce the Cambrian animals? That was my question. But it suddenly hit me because there's a question I wanted to ask. what is the cause now in operation for the production of digital code? What do we know from our uniform and repeated experience about what it takes to generate information in an alphabetic, typographic, or digital form? It's a mind, right? It's an intelligence. That's what we know from experience. In fact, very soon after this, I came across a passage in an early work on information science as it was being applied to molecular biology. And the information theorist Henry Quasler said this: the creation of new information is habitually associated with conscious activity. It's a presently acting cause. And is that true? Well, let's think about our experience. We know that computer code, that a computer program always comes from a programmer. Now, Bill Gates has said, in fact, that DNA is like a software program, only much more complex than any we've ever devised. We know that computer code programs come from programmers. We know that hieroglyphic inscriptions come from scribes. We know that text in a book comes from a writer. In fact, whenever we see information and we trace it back to its source, we always come to a mind, not a material process. So the discovery that information runs the show in biology and that there have been huge infusions of new information in the history of life suggests that a designing intelligence played a role in the history of life. It provides an inference, the basis for an inference to intelligent design. And notice something else about that inference. This is not an unscientific inference. The inference, the argument that I've made for intelligent design is made using the same method of reasoning that Darwin himself made. In other words, this is a perfectly scientific approach to the question. So I leave you with this sketch of Darwin's doubt and what's become of it. The big question is the question of the origin of information. Because to explain those Cambrian animals, you need new information. And what we know from experience is that information always comes from an intelligence. And for that reason, I think there's a very strong scientific basis for the theory of intelligent design. Thank you very much.